Tonight we're going to be talking about functional programming in Scala. So for those that don't know me, I regularly attend the Scala Enthusiast Meetup. My name is Mark Kegel. I have 10 years software experience. I've been doing this for a while. I currently work for a company out of Austin called Vast, and I get to work remote, and it's a lot of fun. For most of what I do is actually, today, a data engineer. So I do about half software engineering and half data engineering. What that actually involves is the really fun job of taking the models that data scientists produce. Hey!
Was that started earlier? Or
well, actually, we're getting started late. No worries. Yeah. Perfect. As long as it's not locked, folks can get in. That's what matters.
There's one more chair up here.
Yeah. There you go. And I've written code in a lot of different languages. I've been writing Scala professionally for the last 2 years. Before that, I was writing just standard Java on the JVM. And before that, C and C++. I've also dabbled in Ruby and Python and lots of other languages. So tonight, we don't have enough time to really do a deep dive into the Scala language. Like the books that are written about Scala are between 400 and 500 pages. So it's not going to be possible to give everybody like a fully in-depth view of what's possible in Scala. So instead we're going to take a little bit different approach, and we're actually going to ask ourselves, how does Scala approach the discipline of functional programming? Because the one assumption that I'm making here is that everybody sort of has some idea of what functional programming is that's here. And if you don't have an idea of what functional programming is, don't worry, because we're going to go over that, or at least my sort of vaguish definition of what that is, which is right here. So this is paraphrased from what Wikipedia has. Functional programming is a style of programming that models computation as the evaluation of mathematical functions. So when I say style, I really do mean style in the sense of let's bike shed the hell out of this. Because in a lot of ways, pure functional programming actually has a nice, tight, well-defined definition. And everything else is an approximation of that. So if we're talking style, how you capitalize your letters, how immutable your data is, that's style. Some folks go as far as to say that it's a paradigm. I'm saying that there's more of a continuum here. And I think that's definitely true because languages like Java, C#, other things approximate functional programming principles, and we'll see how close it is to get to those principles, to that pure functional core. So computation really is this thing of how do I get the bits in and out. So it's not really that complicated, but we do need to at least acknowledge the fact that our computers are twiddling state. They aren't just describing abstract entities. But the nice thing about it is that we can model that computation through these other means, which is kind of what Haskell does, right? So a Haskell program isn't really a program. A Haskell program is a metaprogram. Because what it actually does is when you evaluate that program, it gives you a program that can be evaluated by the Haskell runtime to do something. So it's at this meta level, which is not where most of us live, but fortunately, we'll see this, Scala allows us to live there when and if we choose. So diving down into what the elements of functional programming are, and I really wish we'd made this a little bit bigger. Can everybody read that?
It's a little faint.
Can we turn the
lights
down?
maybe?
Or can we move the projector back? Yeah. The slide?
Yeah, let's do that.
Yeah, very nice.
Better.
It's old school.
That's better. It's also very twisted.
That's okay.
Whatever, I'm not going to mess with it.
Yeah, that
Yeah, if you can dim the lights
Just a little.
because the contrast isn't high enough.
Ah, there we
There we
go.
go.
Thank you.
That'll be much, much better. Okay, so these are as many elements as I could fit on this slide, and I really don't think there are that many more that I'm leaving out. And these are not like rank ordered in any way. I'm not assigning importance by the order that's here. It's more like a functional programming language, especially a pure functional programming language, should have all of these in as strict and sound a way as it can. And so like if we think about Haskell, Haskell is definitely going to have pure functions. Like you can't really write anything that leaks a side effect in Haskell. In Scala you can, and we'll see how that's actually a problem. A functional programming language should have first-class functions. Like, this is one of those things where I think most people would agree that being able to assign lambdas to data or create closures is one of those things that when you try and deal without it, like C just doesn't have lambdas. It creates code that ends up being very obtuse. Function composition, Haskell makes a lot of use of this. You sort of see this in like dotted notation in Java where you'll have a.b.c. That's effectively function composition. The problem is in a lot of languages it's not safe. And actually, let's just go through these rather more quickly. Because I think what we're going to see is that these are the elements. We want to see how close we can get to them with the language that is Scala. Lazy evaluation. Languages take a different approach depending on what they're trying to do. Haskell goes lazy, Scala goes strict. Recursion and pattern matching, we generally don't have mutable states, so you can't write a while loop or a for loop that looks vaguely similar. So we're generally talking about counters and going through stuff like that. Program soundness, this is one that I think is really important because you know when your Haskell program compiles that you should not be having runtime exceptions. Now I've seen some stuff online like you can actually run into runtime issues, which I find really amusing. But all bets are off with Scala, which makes it really fun. Complex types. This is one is probably the furthest from, I don't know, idiomatic pure functional programming because lots of different languages take a very different view on what their type system should be. Scala probably has one of the more complex type systems out there, which is both a feather in its cap and a lodestone on its back. So, and then of course immutable algebraic data. Scala has some of that. So the main crux of the issue is that Scala is not a pure functional language. It doesn't make, well, it makes some attempt to be, but it really sells itself as a hybrid language that attempts to marry the object-oriented paradigms and the functional paradigms into one cohesive construct so that you can express your ideas using both of these approaches to programming. And this is not a bad idea because, to read the Michael Feathers quote, OO makes code understandable by encapsulating moving parts, and FP makes code understandable by minimizing moving parts. And if you have access to both approaches, you can write clean, clear, beautiful, elegant code using whatever approach makes sense for the domain that you happen to be in. And I sort of feel like different schools of developers will be able to find the niche language that they would like to write in and can write great code in that without having to take on, I guess, a very dogmatic view of, no, we don't do that. We only, well, maybe it ends up being dogmatic and, oh, we only use these features. But they can sort of carve out the approach that works for them. And I find that really cool. It doesn't always work, and I sort of think that this, in a lot of ways, puts OO and FP at odds. And I think Scala says, well, why not both? The compromise with this, and this really is the crux of all of Scala's power and all of Scala's downfall, is that it really values, above almost everything else, a seamless and zero-cost integration with Java. You can actually manually transform Java code into Scala. It doesn't look that different. And it will do more or less the same thing as Java. So like all of the problems that Java has, and all of the little unsound semantic gaps that it has in that core, get hoisted over into Scala. And we will see how that affects every single element of our functional programming style. So it's not to say that we don't gain anything by interfacing with Java. We get to leverage the entire freaking Java ecosystem. This is like 1 trillion lines of code. It's not small. It's code that's been written over 20 years, It's bulletproof, it's well tested, we know it works. We get access to literally the fastest JSON parsers, the best XML parsers, awesome web services. And if you guys don't know about the monitoring that has popped up in the last 5 years, production monitoring on the JVM kicks everybody else's ass. Like New Relic, Datadog, those kinds of things are amazing because of how the JVM actually works. And Scala, we just get seamless access to it. Like, hey, we just get it. It's free because that's where we live. The cost of that is that now the language is impure. It has at its core an unfixable impurity because it's valuing integration with Java. Now that isn't to say that you couldn't take a more principled integration with Java. In fact, you very much could. You could have Frege, for example, which is a Haskell that's been ported to the JVM. The problem is, how do you call from Frege into Java and make it safe, and from Java into Frege and make it safe? Well, you can go from Java into Frege because everything in there is going to be a pure function because you know it's Haskell. Great, I don't give a shit about writing more Java code that can call into my pure functional code. It doesn't make a damn bit of difference to me because I want to be writing my new FP stuff. So the real question is, how can I live in my nice little bubble and leverage all of the old legacy code that I've already written without having to worry about interop issues? And that's the point that Scala makes, is nobody cares about calling from Java into your language. It's from your language off into Java. And it's how painful you make that in a lot of ways is going to determine your success or failure. And all of the really popular JVM languages that have come up in the last 10, 15 years, Groovy, Clojure, Kotlin, Ceylon, Scala, make calling off into Java as simple as possible. They do not make it hard. So part of Scala's success is that it casts a very, very big umbrella of the folks that it wants to bring in and introduce to functional programming ideas without necessarily making them pay all of the cost of those ideas. And I think really the most important group that Scala is bringing in are the Java refugees. The folks that don't want to have to write another damn for loop to just imitate map, because that's no fun. We know that our code should be one line. I shouldn't have to write 50 to get that effect. That's just no fun. And you can actually, and we'll look at this in a code demo, you can write Java in Scala. You shouldn't, but you can. And that helps with that learning curve of taking folks that only know Java and bringing them over. The most recent group to really take up the Scala mantle are the data science folks, because of Spark. It's really, really cool what you can do in Spark. Spark is definitely the new hotness. It's going to kick Hadoop. It already has kicked Hadoop to the curb. These guys are leveraging the features of the language to build runtimes and platforms, and now that's infecting everything else, as we were talking about earlier. I think really the last core group that's driving at least enterprise adoption of Scala really are the enterprise bean counters, the folks that look at lines of code and the cost to write and maintain code. While these folks matter, they run the books, they see how productive Scala developers are, or at least how easy it is to drop Scala code in on the JVM, or at least the total cost of ownership of being on the JVM. That makes it an attractive proposition. What's really cool is Scala.js. We've now expanded our umbrella, not only to across the enterprise and the data scientists, we're actually reaching in, and it's very new and it's very fresh, but we've had it for a while. And I definitely recommend going and reading Lee Howey's Why I Chose Scala.js. And it's because you can actually just write Scala that gets compiled to JavaScript, and there's no magic there. It just works. And he presents a very compelling argument for why Scala on the front end is a much more attractive proposition than languages like PureScript and Elm, and even Kotlin, and a lot of the Java stuff that don't actually bring a lot of the core libraries along. Well, we do in Scala. You get access to just regular Scala, which is really, really nice. You don't get access to everything, but the code that the community actually writes Yeah, you get access to that. We have libraries that we can actually bring up into the front end. How cool is that? And we can leverage with zero cost all of the JavaScript stuff that has been developed over the last 5 years. So like if you guys haven't looked at Angular and how quick and easy it is to develop basically single page applications using either React or Angular. Well, we just get that in Scala for basically free. It's awesome. And our code type checks, and it's safe, and we're not gonna have to worry about MPs at runtime. It's really, really nice. And we're sort of seeing this taken up with like TypeScript on the front end, but we get all of that for free. There are 3 other groups that have glommed on to other aspects of Scala, and I'm not saying anything mean about folks, but there is a certain contingent within the Scala ecosystem that they put on their hats and it just has to be Haskell every single day. But the core compromise of the language is that it can't be. It just fundamentally can't be. So they make lots of awesome things like Scala Z, and we'll look at a little bit of that tonight. But we can only go so far down that road, which is unfortunate because we know what it is that we're giving out. So some of the other guys, like the PLs folks that just love new languages, well, Scala gets new things and it's going to be getting more new stuff sooner because we're moving to basically a new compiler platform, as well as changing up the core calculus of the language. So like all of the syntax that we're going to be looking at, most of that is going to survive. But Scala is actually putting itself on a sound theoretic foundation with what they call DOT, the dependent object types. So it's a proven, in that I think they actually wrote a Coke proof, to say that the formalism that Scala is based on will be sound when it's compiled, which I think is really, really neat. The last group is really the academic dreamers. Martin Odersky is the guy really behind Scala. He was originally one of the core guys behind Scala, or Java generics. He runs a lab out of EPFL in, I want to say Switzerland. He has managed to attract a very large contingent of postdocs, grad students that have contributed significant things to the Scala ecosystem. Most other languages that I'm familiar with are not able to actually leverage the academic side of what goes on. Python is probably one of the few ecosystems that has. Well, maybe not half, but significant portions of cool things going on in Scala, like all of our macros, come from the academics. So we've got this huge umbrella of folks that are all glomming on and contributing to our ecosystem. And it's a very wide umbrella. I think it's very cool. And at the core of that, maybe I'm being a bit egregious in calling them visionary pragmatists, but it was really the closest thing that fit the pattern. But it really is folks who are visionary, and that they're seeing further, I think, than other language designers. But they are pragmatists in that they're willing to adopt compromise for the sake of moving the ecosystem forward. So is like a seamless zero-cost integration with Java a good compromise? If you're a pragmatist in today's world, you might say yes. But you might come up with great ways of limiting the downside of that integration. And I think with DOT, they're definitely going to do that. So you can get all of the benefits and limit your downside. And that's really what our core compiler developers are doing. Now I know that Paul P. would have a
DOT
fit.
came out of the academic dreamers, didn't it? That was Odersky leading the dreamers again.
Yep,
Yeah.
absolutely. Yeah, I think Paul P. would have a fit with some of this, but I really don't care. So, and for folks that don't know, he was like the core compiler dev for like 5 years. And left because of the compromises that he saw in the language. So, as well as the runtime and lots of other things.
He left the compiler team, but he still constantly tweets about it and apparently writes tons of code in it. So.
Oh yeah, I mean Scala is a great language. He went and wrote his own collections library, and frankly it's very good. It would be nice to be able to use that if we didn't have a billion lines of code that depended on regular Scala collections. All right. So this is going to be the takeaway of how close for all of these functional programming elements does Scala get. This is really where the drum roll is. Because if you're considering writing, or you have a requirement for I must write pure functional code, or which of these elements do I need, is causing me heartburn in my code base today? I can sort of answer that, and they are not always good, but some look okay. So on the subject of pure functional, or of pure functions, how well does Scala do? It does pretty well. On the JVM, you can certainly write a function, and it can definitely return something, and you have no idea what the hell it might do after that. Because there is no guarantee, especially when you're calling off into Java, that you know anything about the side effects that that code is going to do. So Scala actually punts on the entire issue, in that they have no effect tracking in their code at all. Now that isn't to say that you can't do effect tracking. Actually, Scala Z has an IO monad, and if you follow those primitives all the way through, you can have code that is pure until it interfaces with Java or Groovy, and then all bets are off again. So you really have no idea what is going to be going on. This is more of the community trying to write pure functions as much as they can. So when you encounter Scala code, it's very likely that it will be pure, because that's something that the community values. That's what idiomatic Scala looks like. We make it easy, but there's no static guarantee of purity. So it's best effort. And this is how a lot of Scala stuff goes, actually, in terms of like how well we do. Because, well, what about first-class functions? JVM doesn't have first-class functions. The JVM has classes. Only classes. Now, you might say, well, what about static methods? Well, they live inside of a goddamn class, okay? You don't have first-class functions. So you're really limited by the primitives that the JVM comes up with. Now this one is less of a limitation until you want to pass functions around as data, and then it gets really interesting because, well, now you need somebody to own that class and instantiate that class. And as we've been looking at in the Scala group, decompiling, or, well, yeah, literally decompiling how Scala turns some of these notions into Java-compatible code or JVM-compatible code, well, you might just end up with 50 classes for your 50 anonymous functions. Hey, so there's a definite cost to using some of these primitives. They're there. They're not always free. Now, a lot of this stuff is going to get better because Java has picked up first-class functions, Lambda functions, which is really, really helpful in that we now, our jars will shrink a lot, but we're still limited by what the JVM can do. So, yay. This one is going to come up a lot because exceptions are everywhere. In fact, exceptions are specified as part of the JVM spec. Like, if you NPE, if you dereference null, you have to get an NPE. This is part of the spec. So when you take two functions and you compose them together, is that safe? Do you know that your code isn't going to deadlock? Do you know that it's not going to do any IO or grab a mutex or just go to China for a week? Well, no, you really have no idea because the one in the middle might throw an exception and now all bets are off. This is, in my mind, where Haskell actually shines because you know that your function composition, that composition is sound and will work and that your code should be safe. In Scala, you have no idea because exceptions are going to be riddled through your, hopefully won't be riddled through your code because again, the community has come together to say, well, why don't we do this in a monad? So we actually probably have as many different kinds of monads as Haskell, and we use them just as often, but we're getting around a limitation in our tooling because exceptions are still there. And so like, even the code that I write day to day, I still see null used, which is really unfortunate, but the community has developed all kinds of tools to get around this. But because you're interfacing with Java, and Java has mutexes and threads and IO and all kinds of other things, you really have no idea that the composition of your functions is actually going to be safe. we already sort of talked about the higher order functions that either take, return, or both of other functions. They're classes underneath. Sorry, it's just how it works. We're able to imitate them and they look really good, but they're still exceptions. They can still screw your life up. And the worst part is because of how they're implemented, if you ever throw an exception from an anonymous class, good luck debugging that stack trace. This is actually something that I went and wrote a macro for to help out with, to actually screw with the exception. So it turns out that exceptions are not immutable on the JVM. If you didn't know that, that's a good thing. Turns out that you can basically pull the stack trace out of an exception and put in whatever the hell you feel like.
For real?
For real.
Oh
Yes,
God.
you can do this because I went and wrote code that did. So what I did is I wrote a macro that should it detect an anonymous function throwing, you actually wrap it the same way that you would any other block. It will make the best use of the stack trace it has to tell you where that anonymous function was instantiated, because the only thing that you're ever going to know is where it was evaluated, where it was executed. Because the wonderful thing about FP is that you can separate declaration from evaluation of code. Imperative code, all the evaluation is your declaration. That's why the one guy last week was talking about scope continuations, because it keeps your stack traces sane. The problem is when you're passing functions around on an underlying architecture that only ever knows about imperative code, and you're evaluating it over here, all of a sudden you have no idea, you have this bug, but you cannot find the code. In fact, you can run into stack traces where the entire stack trace is over in framework code with none of your code in that entire stack trace. And that bug is buried deep in your code. And it's because of issues of passing functions around. And so, again, this is a JVM limitation. I say it mostly works. This is about as good as we're going to do here. And it's because of the compromise. It's because we live on the JVM. So if you're willing to pay this price and lint your code so that you never, ever, ever throw exceptions in anonymous functions, then you'll be fine. But the first time some uninformed developer goes and does this, you will have a stack trace that you literally cannot debug. It's fun! Ooh. Lazy evaluation is another one that really does actually work, except for the fact when you compose it, which we talked about earlier. There was a really interesting pattern. I don't know if you guys have heard about it. It's called the cake pattern. It's a way of effectively doing dependency injection within pure functional concepts. So like, for example, one of the really neat things that Scala introduces is the object. The object is a first-class singleton type within the Scala language that is actually lazy in its instantiation. Which means that if that block of code, that object, then depends on other things that are lazy, and those things depend on other things that are lazy, you can get this nice little cycle going that the compiler will not tell you about, that you will run into at runtime, and your code will just... Exactly. So it works, and it's going to get fixed. Actually, in 2.12, we have a fix for this. But you have to be careful how you use it. Again, this is one I've put a green check mark to. This one, we have recursion. We have recursion. We don't have tail recursion or trampolining. So your stacks might just blow up. And if somebody forgets to put @tailrec so that you can rewrite your code, that the Scala compiler will rewrite your code into a while loop, well, your stack might just blow up. It's fun. Pattern matching is actually the one that is more often going to bite a day-to-day developer, in that, well, we actually have Erdersky to thank for this one. We have erased generics on the JVM. Now, some of this might be changing as part of Java 10, where they might allow, at the bytecode layer, some way to reify generics. we'll have to see how that works out. But if you watch the Oracle presentation on the Java language days, that's one of the things that they were talking about. Java will never have that, but we might be able to have that in Scala. The way that this bites you is if you want to pattern match over something that is a type constructor. So say you want to pattern match over a list of int in this case and a list of string in this case. You're not going to be able to. It's going to fail. And it's something that looks like it should work and doesn't, and it's really annoying. And it's because it's just a list at runtime, and that's the only information that you have about that list. Now you can go introspect all of the elements of that list, and you can put in a hack, let's say, hey, is the first element of that list an int? Well, sure, but what if it's actually a list of any? You have no idea what that thing actually coming into you really is. And so it bites folks in a lot of interesting ways. The compiler will usually complain if you're doing pattern matching that can't work. And libraries like Shapeless have introduced some things that help resolve some of these issues and that you can effectively pattern match with even erased generics, but it's still a hack that shouldn't exist in my opinion. And this is the one where we just fail outright. Because we have exceptions. This to me is the biggest compromise within the Scala ecosystem, in that they brought null along, even though there was a reasonable syntax for interfacing with Java code, and that really is just union or and types. And to be able to say anything that comes back from Java land is T or null. It's just anytime you call Java code, or really any other language code, you should just always wrap it up in that type. And the compiler could have been smart enough to do that. And I'm a little bit surprised that they didn't. And they might be able to do this in Dotty. Now, that isn't free, in that you now have to do a null check every time you interface with Java code, but it goes a long way towards ensuring program soundness, because we've actually had issues where I work where somebody's returning null. And now all of a sudden, the rest of your code's blowing up. And it's because Scala's calling into Java, Java back into Scala. You have no guarantees on program soundness. So, this is one that lots of people harp on. There's a wonderful 16th century 3-panel painting that on the left side, it's this sort of mountain prairie, well, it's not a mountain scene, it's a prairie scene with like a lake in the background. And on the left and the right are these really simple sort of Victorian scenes. And in the middle of this wonderful painting is the most egregious mass of people doing shit that you've ever seen in a 16th century painting. It's actually really cool. The left and right sides are like the Scala compiler and the Scala runtime, and that they're both really nice. And then you've got the middle, which is the Scala type system. The Scala type system really does drive people batty in how complex it is, in all of the different things that you can do. Because, well, we have dependent types, and existential types, and generic types, and higher kinded types. And I'm pretty sure the list goes on. Primitive types, algebraic. We have type classes. I think we can do Voldemort types, but I'm not sure. You have all of the different things of category theory that you can actually describe because of how complex the Scala type system is. We really do have type constructors. It's fun, sort of. We have type projection, in that you can do type level computation at compile time. In fact, we'll probably see a little bit of this tonight. The problem is, and this is why they're fixing it as part of DOT, the Scala type system as it exists today is fundamentally broken. So, I mean, we were talking about like program unsoundness before because of exceptions. It's not just the JVM that makes some of these things broken. It's actually fundamentally broken because of how type projection works, in that you can have sort of unqualified projection, which basically means you can have a class and a type member. So you can have a class A, which defines, in some sense, like a type parameter, think type parameters. You can, at runtime, decide which of those classes you're going to pull a type from, and then return stuff back out to. And so when you're writing your code, it's going to look like a meaningless name for a type. But because the JVM can just pass these object references around, you can start to pass sort of like arbitrarily bound data around, which is not safe at all. And so there's actually a really nifty little, in the bug report, something that chooses between int or string. Well, it can't be both. Now you can pass back a reference to int or string into something that won't type check it. But now do you add it? Do you two-string it? What's safe to do with this object? Well, it turns out to be unsound. The rest of it is good though, in terms of like how complex the types are. The rest is sound and actually really quite nice. And the unsound will be fixed, I think, in 2.12, which is nice. Or no, in Dotty. It won't be fixed in 2.12.
Yeah, by 2.13.
Yeah. This is one, I think, it's the immutable algebraic data. This is the one, I think, that actually is sort of the feather in Scala's cap, in that even though it's horribly broken, because you have, again, no guarantees because of how the JVM works. Because you can always take a class, and you can always do reflection, and you can change whatever the hell you feel like. Or you can just, rewrite bytecode or whatever. Looking past all of that, Scala actually has a very nice, concise way of defining both algebraic data types that really are safe when they're used from Scala, and really are immutable by construction, though. Not by any guarantee of the runtime. They're immutable because the compiler won't let you mess with them. Well, that's a kind of immutability, right? Please? And they really are algebraic in terms of being able to know how many different kinds of something there are, kind of like enumerated types. If you have, for example, a tree, and you know that a tree is either a leaf or a node, well, and you pattern match over that, if you write the Scala code correctly, you can actually know that your match statements are safe. They're provably safe. They will encounter and handle all possible permutations of the types that you're sending in. Now that isn't always true, and we sort of hinted about that at the pattern matching of, well, sometimes we fail. Enumerations in Scala is actually a really good example of not having completeness guarantees around our pattern matching. But for the most part, our ADTs actually work really well. And it's sort of the first thing that our Java refugees glom onto, because what would be a class in Java that's like this is 1 or 2 lines in Scala. And that's where a lot of our data savings comes from. So I don't want anybody to walk away from here thinking that Scala is a replacement for Haskell. It's really, really not. It's a terrible replacement for Haskell. It is a wonderful replacement for Java. And that's really where on this continuum we live. In that if you really do need to write pure functional code, go for Haskell, go for Frege. Like, go nuts, have fun. But if what you're really looking to do is replace Java, but get more functional with the compromises and limitations and caveats that I've outlined, then choose Scala, because Scala is actually a reasonable approximation of functional programming on the JVM. Again, we see the caveats, with all of the compromises and seamless zero-cost integration with Java. All right, so we haven't seen any code. What the hell does this stuff actually look like? So let's apparently, oh, okay, where am I? All right. Oh, does anybody have any questions? We've gone for most of an hour.
Java is going with functional programming too, right? So
Well, how many of those elements does it really bring in?
I don't know.
Well, so we don't have pure functions because we have no notion of purity in Java. And Java punts on that as well. Like, there's no notion of purity. You can't mark your functions pure or impure or anything. Now, they actually talked about doing some of that, but I have no idea how that would work. And would increase the cost of integration. So whether or not they do it, I don't know. It depends on that pragmatism cost-benefit analysis. First-class functions, sort of. You have what are called SAM types in Java. Singleton and abstract methods, or whatever it is. Basically an interface that has one method. So then it can sort of sugar you a new class from that method using that sort of concise notation that they basically stole from every other functional language out there. So you get that, but you don't get, say, function composition at all. You have all the same problems in Java as you did before, but again, those are problems in Scala as well. You don't, I guess you would have higher order functions, but they're not really functions. Again, they have to be bound to an interface. So you're still back in the land of nouns, as I forget who it was said that. But you can't really treat functions as data. You're still treating functions as classes or as objects. Lazy evaluation, Java has no notion of lazy evaluation. Recursion and pattern matching. I mean, you can get recursion. You can have functions that technically call themselves, but they're not necessarily safe. They can still blow up the stack. And Java has no notion of like how to unroll those things or detrigger them into while loops, into tail recursive calls. You have no pattern matching that isn't available in a library. In terms of program sadness, I mean, null is the bane of a Java programmer's existence because it shows up all the time. It's going to be better because of optional in Java 8, but there's billions of lines of code that already exist. So you're going to have to wrap now every call off into those other libraries and then optional and then unwrap it safely. Is that actually going to happen, or are people just going to call the functions directly? Well, I can tell you which one is higher cost. So, complex types? No, actually, Java doesn't even have a way of doing higher kinded types. So in terms of even like being able to do monadic stuff, Java falls down completely. So some of the stuff that is bread and butter to a Haskell programmer is just fundamentally impossible to describe in Java. And then in terms of immutable algebraic data, immutable here in Java is very much by convention. And writing data holder classes is actually extremely painful in Java. I mean, that's why you have the IDEs that say, generate me your getters and setters. So I would give red X's to almost all of this in Java. Like, they now have lambdas, and that's good, but they lack literally everything else.
It'd be significantly difficult to modify Java to include the others anyway. You'd be fighting so much legacy pattern.
Oh, yeah. It would be terrible.
One of the benefits of Scala was Odersky tried to push everything he possibly could into the libraries and out of the language. That's not the case with Java. So each time you try and add something to it, you're fighting all the pre-existing internal workings of the Java language spec.
Just because I have notes up. All right, so let's actually look at some code. Before I get started, I want to introduce everybody to Ammonite, we may be forced to drop back into the Scala REPL, but there is an alternate sort of REPL for the Scala language called Ammonite. It's written by a guy named Lee Howie, who works actually as a Python developer at like Dropbox or something. But this is very, very cool in that it extends all of the regular functions of the Scala REPL, and it will make it far easier for you guys to read because it does a little bit of syntax highlighting. So, all right, so let's look at some of the basic constructs of Scala. So say I want to declare a variable A. Well, I can. The syntax is a little bit different than Java and very different than Haskell in that I can declare a variable, sort of a binding, and I can bind it to something, And then I can change what that value is, sort of at will. So A is now 3. And the way that I did that was by upfront saying var. So var is Scala's way of saying that this reference up here can now be rebound to whatever it is. So in functional programming terms, we would have single bindings. So we would be able to say val b is 1. And what val does is it says if you ever try and bind to this again, that's an error. Reassignment to val.